The mid-Atlantic seafloor is commonly thought of as sand, mud, the occasional shipwreck, and artificial reef. This view ignores large areas of naturally occurring substrates that form temperate reef ecologies. While many of these habitats offer only a slight vertical profile, others are quite robust. It is these naturally occurring areas that form the backbone of several important commercial and recreational fisheries. Should an intensive study of these reefs occur, it will show how all these areas form a mosaic of habitat, and when pieces are removed, the overall production becomes diminished. Sea bass, lobster, and tautog now represent the dominant species. However, in the not too distant past, codfish, scup, and red hake also thrived in the region. Boulders, smaller rocks, hard clays, and sandstone slabs form the substrate for these areas. Alone, they are the most basic element of a reef. However, it is the settlement of myriad filter-feeding animals, such as the grass-like soft coral sea whip, the star coral, and a great many other species that make a reef's biological production possible. For it is this greater complexity, the hiding places great and small, that allow juveniles of many species to survive to maturity. Commercial and recreational fishers have long targeted these areas, some of which were so large they were easily found in the era prior to precise electronic navigation. Many marine species exhibit a strong habitat fidelity. As electronic navigation became more precise, new areas were discovered and targeted for their larger class of fish. It was also during this time of improving navigation that the stern-towed gears were able to work closer and closer to known snags and obstructions. As is shown by this lost gill net, virtually anything that will stay in place on the ocean floor will act as an anchor for a reef ecology. This type of reef may not always be beneficial. That ghost gear continues to fish is well documented, but its cost to the region's fisheries is completely unknown, as is its effect on populations of marine mammals and sea turtles. Flounder are another species that use the region's hard-bottom substrates. It is this species that causes the most conflict between commercial user groups, as well as the wording of the Magnuson-Stevens Act. The pursuit of any species by trawl or dredge has been well documented by fisheries scientists to have long-lasting negative effects on seafloor habitat. Large, robust substrates are more resistant to damage and have remained largely unchanged during the period of increasingly industrialized fisheries. When encountered, gear loss, higher trip expense, and lost fishing time are frequently the result. That conflict occurs between the commercial trap and trawl fisheries is well documented and is starkly evidenced by this huge tangle of trap and trawl gear that was lost due to a single rock. It was on the lowest profile substrates that a resurgence of growth took place during the 1990s. Management actions of size and landings limits for flounder almost eliminated trawl impacts to some more distant habitats. Fishers were able to fill their meager quotas fairly close to port. This allowed for the recolonization of large areas of hard-bottom substrate and better juvenile survival ratios for some fin fish. More recently, quotas have expanded and trawl effort has as well. Unfortunately, this has resulted in the loss of habitat complexity in several areas. Without guidance from managers, fishers will naturally return to areas that have been productive in the past. This, despite increasing scientific certainty that it would result in decreased production for temperate reef fishes in the future. The essential fish habitat definition in the Magnuson-Stevens Act seems quite clear. EFH is defined as those waters and substrates necessary to fish for spawning, breeding, feeding, and growth to maturity. The Sustainable Fisheries Act further states that each fishery management plan must, describe and identify essential fish habitat for the fishery, minimize to the extent practicable adverse effects on such habitat caused by fishing, and identify other actions to encourage the conservation and enhancement of such habitat. Even though fishers have targeted these temperate reefs for as long as anyone can remember, they still await discovery by managers and the scientific community. As the existence of these reefs become known, fisheries managers can begin to use the growing body of science surrounding marine benthic habitats to maximize the production of several economically important species. As more studies of the mid-Atlantic reef system occurs, the importance to the broader-based ecosystem will become evident. The mid-Atlantic seafloor truly is mostly sand and mud. There is room for every gear type. Clearly, any cooperative effort between scientists, managers, and fishers will begin by recognizing the importance of seafloor habitat and acting on and gathering more knowledge. Only then will the mid-Atlantic reef system become a more vital part of the marine ecosystem and its associated fisheries.